Welcome. We're in a little bit of a different room here, but still going to be an interesting talk, I think. I'd like to introduce Robert Cooksey. He's from the Intel Perceptual Computing Lab. Robert was here actually last semester talking about various issues with perceptual computing in my group, and I thought it would be interesting that you'd be able to come back and do a talk about some of the things that he's doing and Intel's working on, maybe a little bit about what it's like to work at Intel and the Perceptual Computing Lab. So without further ado, Robert Cooksey, let's give him a
Guys, so first off, I'm going to make a disclaimer that I am not an engineer, regardless of what Intel says in my title. My training is actually philosophy. That's where all my background has been, my academic training. I've worked in technology pretty much the entire time I studied philosophy, but my interest was really in mediation and the way humans think when operating and interact in spaces involving technology. So that's kind of where I spend a lot of time thinking. Before Intel, I was at Ringling College. I was building the game art and design program there. It made it to where I dreamed of it going as far as I could go with that, and then at that point Intel showed up and had this thing I couldn't say no to. So say a little bit about perceptual computing. So kind of just I don't know how much anybody knows, so if it seems kind of basic to you, just let me know. But when we talk about perceptual computing, what we're really talking about is computer sensing. Basically, a concept that we're going to bring senses to a machine, and then we can interact with them. So machines in the past have always been processing information for us. So we've had basically largely been going to it and using constructed interface objects, physical objects, in order to put that information in. I think of computers as always having been sensing for the most part. When you're reading punched cards, that's a form of sensing. Since you're taking something physical and reading it into a digital space. Joysticks are physical. I'm using a directional control in order to manipulate a pointer that traverses a space. So I'm translating my physical movement into something. So I think we've been doing this for a long time. The difference is it's getting better. And there are a few places out there that are doing some pretty interesting work here, including here, actually. This is how I ended up here. At the lab here with these guys was a guy here who was very interested in some of the research that was happening here. And through the grapevine, I got to come check it out. So one of the things we're starting to see is we're basically beginning to interact, and the real focus is interacting with machines largely like we interact with the world is really the key. So the way we interact with people in some regards, you'll hear people focus on that, talk about that a lot, about emotion detection and things like that. So if we're sitting here and I notice, for instance, I start to drift, people's phones come out, etc., I probably lost you, right? Those are things I'm starting to pick up. I'm noticing attention differences. I'm noticing those sorts of things. That happens at a micro level all the time for us. Same thing with physical objects, right? So if I pick an object up, like there's all kinds of stuff happening on my skin that's telling me how much weight is going on here. It has almost nothing to do actually with the physical weight of the object. Almost everything to do with my skin. And that data is coming back to me and telling me things that I'm reacting to. We want to start to bring that to the machine, so the machines can work with us in ways that allow us to be more efficient and more comfortable with what we do. So one of the things, the kinds of things we're talking about doing is basically extending our computing capabilities using this sense-driven awareness, basically. That really is what Perceptual is about. Perception is really about sense-driven awareness, and that there's a number of pieces in that sense-driven awareness that you have to take apart. The first step is sensing and hardware, and that's one of the things we're right now in the stage of doing it at Intel. We're at a stage where we're building new technologies. I can't talk about specifics right now, really, but some of those. But I can talk about some of the general. That we have one camera that's out in the developers model. People have been using it. Using here. We have a new model that's coming out. It's on a completely different technology that will be coming out in laptops this summer, probably around October. They should be out in stores and people picking them up. Already a number of OEMs have signed on. Companies that are going to be building them in, so they'll just be depth, those kind of sensors built into the bezel of your laptop. And they announced, I believe at CES, that we're going to have those in tablets next year. So not only will you have user-facing cameras, in your laptop, you'll have world-facing cameras on a tablet, so I can walk around and look at the world through a camera that's being able to do some sensing of the world and feeding that into the software applications on tablet-based technology. I want to show you this is kind of the vision video. This was done some guys in my group actually. And the idea was kind of just to show what the vision is for the kinds of things. Now, don't fixate on the specific interactions because it's not really, really isn't about interaction so much as it is a feel to give you an idea of where we're headed, like what the target is. So I'm going to show you that video real quick, short. It's kind of just like a feel video, kind of the directions where kind of what we're looking to head toward. The idea being that these are kind of playfully interacting with the machine. You notice there's some markers in there trying to give you an idea of what we're looking at, but it touches on some of the key technologies we're focused on right now. I kind of to give you an idea of what some of those are. So, like right now, some of the things we're doing are really looking at things. When you're looking at this and you see the scans on the robot, for instance, right? You have a little robot that he's playing with. You see a little scan. 3D reconstruction is a big deal to us right now. So that's one of our major efforts is to be able to look at the world through various types of cameras and then interpret that data into geometry that can be used in a 3D environment immediately. And this is a proof of concept for that. We actually at CES this year did this guy. A couple of guys in the lab did this. So turn off the wall, you can talk me through it. So what he's doing is he's got this tablet here, and what he's done is we've got this sandbox we've been playing with, and you can see these kind of radars. And this guy just flew down and landed. So what he's doing is he's scanned the terrain, he's created a 3D mesh of it, and now this character is flying around adjusting to the physical terrain that's in front of him. And what you're seeing on the screen there is what he's looking at on the tablet. So he's now got this bot, the bot's looking around, can play around with it. So one of the things he's going to do here in a second is he's going to start to add in objects. So like one of the things that was kind of the way we won this one, basically the way we convinced people that this was doable and they should give us the resources to do it was in a hotel room, actually just oddly enough, and this is how these things happen, was the guy's given a proof of concept to one of the execs, and what he does is he takes a dirty t-shirt off the floor and throws it onto the bed, and then the bot flies around and is occluded by the dirty t-shirt. Like, that was it. That did it. It's like, okay, got it. Go. Like, so keep going. So this is what they're going to do now. You'll see in a second. It'll come in and it'll put some blocks up. The main thing I want to show here is basically what we're doing is there's a number of pieces of technology that are happening here, a number of pieces of kind of problems to solve that come together into what feels like a single experience, right? And that's kind of what we're looking at with all UX happening. So what ends up happening is basically you've got this kind of sand situation. You're reconstructing the space. We're creating a 3D mesh. We're bringing that into Unity, where in Unity we can take that mesh, use it as a ground. We can animate a character. We can have the character follow the mesh of the ground and adjust its animations accordingly. This is basically just a rendering so you can see what the bot is seeing, what the AI is seeing. And it can also do, didn't include it there, but that if he were to go behind those blocks, he'd be occluded. And the idea is that we can handle the geometry, but once we know the geometry, then we can do everything we do normally in spaces that would be game spaces in the past, right? In the past, we've been doing that in games for a long time, right? You have a 3D character, it walks behind a 3D wall, and it disappears. So how we can do that? We just can use the real world as the source of content. So I just walk through the world, I'm getting content from the world, and my virtual objects are interacting with them in a way that makes sense. So if I walk behind the computer here, if my guy walks behind here, he'll just disappear. Up the other side, I'll see him. Because we have depth data. And that's really the key. Right? We can understand where this character is in the space, where another character is in the space. We have some simpler versions of that I can't show you right now, but I think I can explain to you. But Seth, for instance, has been working on just using depth data alone to do things with just playing with butterflies. So it's this like silly little prototype he did, where he's just taking butterflies and he moves his hands around the butterflies. They'll fly around his hands. It's him kind of playing with them in this space like this, and they're flying around him. And it's just a matter of knowing where is the character in 3D space, where are those pixels in 3D space, and where am I in 3D space. And so we can represent that. So this has been going on for a while, right? Since Connect Hacking, Lee and those guys did a great job of convincing Microsoft to open the SDK in the early days, and some great stuff came out of that. Unfortunately, if you guys know that.
It was in the medical, they did stuff in the medical. They did a lot.
There's a movement called creative coding where there's a lot of hacking going on. The problem is in that community, first of all, it's really innovative, it's really exciting, but everything tends to be small projects. They tend to be interesting proofs of concept, really cool stuff, have big wow factor. That's great, and it gets people excited. It's absolutely necessary to kind of continue the development in the space. One of the problems, one of the things, that doesn't answer all of our questions, right? So some of those things we have to do, you really have to take time and understand, well, okay, now I'm excited about it, now how do we put it to work? And that's something that's not so straightforward. Right? You get a wow, you get that initial attention, that drawing of attention, but how do you hold the attention long enough where people can see this actually being part of their lives? How do engineers, designers, people who make this stuff, how do they make decisions about what works and what doesn't? We don't know yet. Like, we're trying to figure that out. And that's kind of where we are right now. And that's largely what happened in Professor Viola's lab. I'm going in there, and immediately it felt like home to me. So we walked in and said, oh, this is exactly what it feels like in a lab. It's a really nice mix. So to talk a little bit about that stuff in relation to what's happening generally in the field, so I'll kind of give you a quick layout, and then I'll talk about particularly working in space. So, first of all, this is a tiny space. We used to joke about games being a tiny space, right? It's a very small space. Once you know somebody, you know everybody, and it's how things work. I haven't applied for a job since 2000. I think probably 2000 was the last time I applied for a job. I was still in college. I was still an undergraduate. No, it was even before. I was in 90. Anyway, so I applied for a job to be a student lab tech when I was an undergrad. And ever since, all the jobs I've had since then have been because somebody I knew there was an opportunity somewhere and said, hey, I think you'd fit here. And it was just kind of one thing led to another. That's how all of my jobs have happened. And that's really common. And you guys should understand that that's kind of part of something you're building here you should be aware of.
Networking.
Well, not just networking in the sense of, there's networking, like in the sense of like networking, but there's also the sense that people are getting to know you. So they're knowing the way you work. They're starting to get a sense of how you work, how you think, how you approach problems. I just did a pitch, a 3-day run, and we were talking about this. We had a situation where there was a major piece of software that has to be made and has a deadline. And the contractor that was contracted for it dropped the ball. They didn't deliver something that was compelling. They delivered good content, it just wasn't compelling enough. And so they dropped it on my team, and we were given basically 3 days to do what the other team had done in 2 months with a lot of time, with a lot of money. And we pulled it off. But what's funny is the first person I pulled in was a former student of mine. Like, I knew that guy knows, I know how he works, I know how fast he works, I know what his skill set is, and I know we can work together. So that was the guy who came, that's who I pulled in. Sure enough, he and I are sitting at 3 o'clock in the morning, kind of handing off pieces to each other because we've done it before, we've been there before. And those are the kinds of things you're doing right now. Seth has worked with other of my students. That's how he turned me into block. And so I just want you to be aware that that's happening now, and it's going to continue to happen throughout your career, particularly in a space like this that's unthought. Like, this is an unthought space. An unthought space is we're all aware of everything that's happening in this space all the time. And you see something happen, you immediately rush over to read, like, oh, these guys, if I see these guys have a new paper, I'm going to go read it, because I know the last 3 papers they published were really good. And that kind of starts to draw you in to kind of knowing who the community is. So, to give you an example of that, as I was at SIGGRAPH this year, or last year, 2013, I was at and Seth and I were giving a talk, and in the course of the talk, we were discussing gesture languages. And my opinion is that we're not ready for them. We're not ready for gesture languages. We don't know enough to know. Crafting a gesture language is a complex design problem, and we don't know enough to answer the questions we need to answer in order to be able to craft those, in my opinion. But I think we know enough to begin to explore them, and we can do them in what I would call dialects. So I get localized, specific dialects where we can explore these kind of interaction languages or interaction dialects that allow us to kind of get a handle on a particular space. And over time, some of those might bubble up and become more general. There was a guy in the audience who disagreed with me pretty solidly. And we had a very engaged conversation about it, which was good, actually. I'm glad he was there because he provided the counterpoint. And that's exactly what we needed. We needed that discussion to happen. And his opinion was we basically need to put together a board and kind of come up with a generalized language, et cetera. So you had this rather engaged conversation. Afterwards, there was a guy who walks up to me, an Israeli fellow, and asked me if I want to go have a beer. I said, sure. And what I found out was, so the Israeli fellow was the guy who had basically had my job for Prime Sense. The guy, and what he told me was that the guy who I'd been just talking to, who he knew from somewhere else, was the guy who has our job at Apple. That's all in that room having that conversation. Right? We don't know who we're talking to. We aren't familiar with each other. But I was like, oh, that's the guy who did this. Yeah. And then Apple bought Prime Sense. Right? So this is kind of, but Apple bought Prime Sense. But Prime Sense made the first Connect. Right? So the original Connect was made by Prime Sense. The OpenAI drivers that everybody who works on Linux uses were made by Prime Sense. That was a small Israeli company also. That was then, they had a deal with Microsoft. Microsoft decided to move off and move to another technology. Those people, instead of being with Microsoft, had to figure out what they were going to do. They started trying to do pushes independent. ASUS worked with them, et cetera. And then Apple buys them. So now this guy has been kind of through, and you've already moved through every major player, per se. Which kind of the reason I say that is because I want you to get an idea of how, at first when I came in this, we weren't sure. Every day we weren't sure whether or not Intel was going to kill our program. We were just trying to keep impressing people enough that they would just write another check. Just 3 months, 3 months. We got lucky, we hit a jackpot. And then we hit the double up jackpot, and that wasn't so lucky. Because when you hit the big jackpot, basically you ask for money and then they give you 10 times what you asked for. What that means is you can't fail anymore. Right? Now you have to deliver. There's no excuse. And so that's where we are with this technology, which means Intel's gone all in. So not only have we gone all in, Apple bought Prime Sense, and now Apple is doing something that none of us know about. And being Apple, that's probably the way it's going to go down. They're going to wait until they've got something right that feels good, and it fits exactly what they do with their brand and their design flavor, and they're going to release it. Microsoft, in the meantime, has gone their own route, and they have this new Connect SDK. As soon as they know that Apple's buying Prime Sense, they realize they have an opportunity to grab a development community. So they start making big moves in order to kind of make their platform more available and more open. So there's a lot of movement going on here, a lot of play going on here. The guy who sits next to me at the lab, is from Croatia. His cousin, who's also from Croatia, works at the Microsoft Research Labs that's doing the stuff that basically is our version. So there's constantly conversations going on between us. We can't talk about exactly what we're doing, but we're always exchanging information. And that's what this space feels like right now. So I always assume if I meet somebody who works in this space that we're going to work together at some point. Right? Eventually, we're going to bump into each other somewhere. Right? It's going to happen. It's just too small. Even if it's not like like in a job, we're probably going to work. We may work on a project together. And that's kind of what the space is like. And working in our lab, it kind of has to feel like that. So, when we come in, we don't know what our technology is going to be. So, because it changes, right? So we've got Intel right now, to give you an idea, we've released this real sense technology. We've got the laptops coming, the tablets coming. Amazon has gotten into the game. We were recording some statistics that Amazon announced there was a big leak. Amazon didn't announce it. Amazon's trying to cover it up. There was a leak from someone on the team about the project at Amazon where they've got a camera with a phone with 4 cameras on it to handle depth and a 3D interface. So they're going after Apple all guns blazing. That's an obvious shot at Apple. Right? That's who they're going after. And Google and Apple are already at war. So there's seriously a trade war going on there. And Samsung,
Yes.
Motorola, they're bringing those guys in because all those guys become part of the players. That's actually a comment I heard by somebody once, is that we're not being sued in this space. We're like, oh, we're not being sued. It's a problem. It's from a lawyer. And why is that a problem? Because anybody who's doing anything interesting is getting sued. Funny space. But the space of what's happening here, there's all this development going on. People are working in different spaces. So at Intel right now, we've made a move from, well, last time I was here, we were in the sense of getting that momentum and trying to get the attention of a larger company, and then trying to get the company to put resources behind this in order to give it legs. So that's happened. Now we're at the point of what they call being pregnant, which is basically it's going to happen. There's a release date, like a soft release date that we have internally, and it means like it doesn't matter whether or not you think it's ready or not, it's happening. So you got to make it happen now. So it's now moved to the point of being kind of a business, and that changes the way we get to play. So my life has changed significantly in the last 2 months in terms of what I can do and what I have to do. And it has drawn very much an attention to the need for us to have engagements with places like this. Because we just don't have the resources now to do both a new business development push and like exploration for practical UX in that regard, and be able to do research in all the spaces that are emerging simultaneously. It's just impossible. There's too many problems to solve. There are just too many problems to solve for one group to do it, or one company to do it, or even one industry to do it. It's really getting big. To the point, I want to kind of bring this back here because I want to kind of frame the different kinds of problems that are starting to emerge and what we're looking for. So one of the things I did before we came here is I went through the lab, and then I went upstairs and kind of wandered around talking to guys, just a perceptual group across the board, and asked them to describe their ideal colleague. It's like, okay, so if you're hiring a guy out of college tomorrow, right? We've got a guy who's coming in, he's right out of college. What does he look like? What kind of skills does she have? Right? And of course, this is people. Some of them are from computer vision backgrounds. Some of them are 2D people. Some of them are 3D people. Some of them are software engineers. Some of them are project managers. Some of them are creative coders. Some of them are designers. Right? So it's a really different point of view from everyone. I thought I was going to get a different point of view, and I didn't. What I got was basically a description of a lot of the people I work with, which are people who are intensely curious, like curious to the point of almost being a danger to themselves. I noticed some hardware floating around the room, and I came a little earlier. Like this is, I don't know if you guys saw, we made a Jedi vending machine. I don't know if you guys saw that vending machine, but
You want the Dr. Pepper.
These guys at IU started it, and they built this kind of prototype, and we liked it. And then I had them send it to me, and then I took it apart and rebuilt it so it was more robust. Luckily, I worked with a physical engineer, so he understands pneumatics better than I do. So, finished. I'll spare you the music.
That's okay.
Yeah. So they, basically this is the setup. You've got a camera. It's a vending machine. It's like a rack of a set of shelves. Behind this vending machine, and, it's kind of brand, etc. In the box here is a camera with a, it's an RGB and a depth camera. Behind this is a tubes, or basically tubes. They're a plumbing pipe, PVC pipe, that runs up behind everything. Those are running down to a canister, a large body PVC canister that is loaded with pressurized air. And that has controlling it a valve for a sprinkler system. Just the solenoid for a sprinkler system that kicks on and off. And then that's controlled from an Arduino board. So this is a processing sketch. And processing basically is handling the detection. So what you'll see here is as he moves his hand over things, you'll see these lights light up. That's the soft select that says, okay, I'm hovered. This is the thing I'm selecting, right? So you see these lights. That tells you, you want the change. Feel the change. So, and then you grab to pull the item, and Yoda gives you a little vote of encouragement. There's an audio file that basically tells you, feel the force around you. And then, chooses it, and then after the duration, So we refined that a bit, put a trap on it, and launched water bottles. It was suggested we launch beer cans at a conference, and I vetoed that. Numerous. Yeah. There was only one of all the possible outcome cases. There was only one that was good, and all of the others were disastrous. So that's you don't want to hurl a can at someone at high velocity. Probably not a good idea.
Probably a lot more pressure than that thing.
Yeah. So you get the idea. So basically, you have a physical object being controlled, kind of it's playful. But this is the kind of playful stuff that goes on in the lab sometimes, right? So this came in, and they were like, okay, cool, you got a week. Take this thing apart, rebuild it, make it robust, take it to a conference. So, okay, I've never done pneumatics before. So what? Learn pneumatics. Go. I understand solenoid valves for sprinkler systems. How do I get a 24-volt, an AC valve to be driven by a battery in a remote location because I don't have power, right? How am I going to do that? Buying batteries and strapping them together, and then playing with relay switches and constantly okay, cool, we'll have to, guys have to handle it, right? Figure it out. And that's pretty much what we're doing. And it started, what we're seeing is this weird mix of software with physical design, and physical interaction, and a little bit of electrician work. Like I'd love to do an electrician 1 course, to be honest. Now I go back and I should have done an electrician 1 course 20 years ago. The amount of benefit I would have gotten out of that would be amazing. So now I just spend a lot of time on YouTube, a lot of time reading files, and at the library going through manuals. But so that intense curiosity. The reason I mention that is because that's how these things come about, right? I'm going to do something kind of weird. I don't know how to do it. I have to learn everything I have to learn in order to be able to do it. And if you're not only intensely curious, but somewhat obsessive enough to be able to pull that off, then you probably never do it. Like you really need to be able to maintain the attention and the focus long enough to actually accomplish it. That's where we see the fall off often. We'll see somebody get a great idea, and then they don't hold on to it long enough and keep the attention on it in order to be able to finish it. Or they've got that kind of attention, but they're not able to do lateral thinking very well. They can't switch off and think about alternative ways to accomplish the same thing. So, you fixate on one problem, and it's that becomes the problem. When it's not really the problem, that's a problem with their solution. And so you remember that you can always go back to your problem and reimagine. Right? So that was another one of the things that came up. We realized that often when we've had delays or problems, it's been because we had a problem, We framed the problem, and then we stood and stared at the frame forever and forgot that that's not the problem. Like, you know, that's just the way we framed the problem. And it's helpful. You know, you need to do that, but sometimes you have to be able to reframe. And then there were a set of skills as well that people talked about. Right? And so the skills that kept coming up were things like, first of all, just a good math background, linear algebra. Right? If you can't do any of this stuff without being pretty solid in linear algebra. You deal with matrices all the time. You're dealing with quaternions all the time. You know, good vector. You just have a great grasp of vectors and understanding of vectors. Those kinds of things. So those are the kind of a good, basic, solid math understanding. And then with code, this is what's funny with me, is like, when I came in, I was a scripting kid. Like I wrote scripts, that's all I did. Like I worked with PHP, and I worked with Python, and I worked with Mel, and, like Maya, and kind of 3D programming software, and those kind of scripting languages. Lua, you name it. You name the scripting language, I probably played with it. But I always stayed away from C++ because that's what real programmers do. Right? Like, I wasn't a real programmer. I was just a script guy, right? So, and that was kind of my thinking on it. And then I realized that some of the stuff that's being made, C++ is all you've got. Like it's the first language that gets access. It's kind of the general language, right? So, so I went to steps as well. I was given a problem. It was actually this problem. I was given the challenge to measure objects with a tablet. So just like point at something in the world and tell me what its dimensions are. So, fortunately, the only drivers I had, the only thing I had for this particular prototype was C++. And I've never read C++ before. Never used Visual Studio before. So that meant I had to learn Visual Studio and C++ pretty quickly. So I did. Basically taught myself the ability, enough to handle them. Nice thing about having a problem is it scopes your problem. Right? I have a problem, I don't have to worry about learning C++. I need to learn the C++ I need in order to accomplish the solution to the problem I have. And so that scoped the amount of, and then as I was doing that, I began to bump into things. I just took notes as I went. Like, these are weaknesses I have that I'm going to have to come back to. Because for me to be facile with this, I'm going to have to come back and learn about these. So it was an opportunity to kind of frame what I didn't know and what I needed to know. What came from scripting languages and what didn't. This was a simple version. It's a solid box, right? You see, this isn't great. I'm getting lots of segmentation here. I'm getting some errors. You'll see my fuzz. By the way, the reason this is missized is because this was an early prototype camera, so the RGB and the depth were, when it would redraw the RGB, it would draw it small. So it's actually the right size. And you see it's kicking out dimensions. I don't know if you can make those out down here. It's 90 millimeters by 144. So this was a challenge. We got close. Like the segmentation over time. So what this revealed to us, as when we did this, was, this is another one that's more complex and problematic, was that I was getting pretty close. But to do it, I had to first segment the object from the world. So decide what was the object I was measuring. So there are a lot of different ways of doing that. There's some 2D techniques, there's 3D techniques. So that I had, basically had to go. I didn't know enough about all the techniques I needed. So I ended up working with a guy who was one of the original coders for OpenCV, and a guy who was a 3D guy. So between the three of us talking about the problem, we kind of narrowed into a possible solution. This was quick, by the way. This was really quick. The suggestion for management was like measure. Right? Put little measuring bars in there and draw from here to here, and then you can measure from there. That's great if I just want to measure an object. But what I was concerned with is that I saw segmentation coming. This 3D stuff where we're looking around the world, right? I don't want to have to touch every object in that room and measure it. Like, I need that measurement to be happening in the background. I want to know, for instance, if I reference anything references that image on the back wall, we already know what the dimensions are in real world. So anything I add is immediately I'm already pre-segmenting the world and measuring it for ways that are meaningful to me in the software space. So that's why we went with that. But the problems we run into here is you have segmentation. Then once we have the segmentation, how do we measure? How do we make a move between the image space and the world space? what are issues with cameras? Camera distortion issues, in terms of measurement, because a millimeter is a pretty big deal in the real world. It's not so much in a flat space. I look at it, I'm not going to see the difference in a millimeter. It's going to look pretty good, right? But when I go to touch something, that might just miss it completely. So these are pretty interesting problems. So these are the kinds of things that are starting to show up. So what that led us to, again, so 2D, OpenCV, like traditional computer vision techniques, and then depth techniques. What are the differences? And for a long time, I think what we were seeing is people saying, oh, depth is going to replace those 2D techniques, which always seems crazy whenever we hear. Anytime you hear somebody say that something's going to replace something else, it's probably a short-sighted solution. It's probably going to supplement, and then something will kind of slowly fade out, and eventually will become something that's neither of those things that does what they all do and more. And so for a while, that's where we were. We were really focused on depth. And then we brought Bob on, who's the OpenCV guy, and we started looking at ways we can combine 2D and 3D techniques, or even use 2D techniques with 3D buffers in odd ways to get some interesting solutions. So in order to work in a space, if you're working with this kind of stuff, you really need to start kind of getting a grasp on computer vision. What are some of the techniques to do that? What are classifiers? What are some common classifier methodologies? Things like that. So that's another space. So those are the kinds of things we're starting with. Depending on where you are in the development pipeline, those are different kinds of things you need to do. So break that up for you to see what that means in the real world for us is, if you're Perceptual is pretty small. Kind of really small. We have, I think, total in our group maybe about 200 now, and that includes all hardware, all software. There's 300 if you count the guys who are in another division who aren't part of Perceptual but are writing software for us. But about 200 people do everything, and that means UX, testing, everything. And it's going to have to grow. So you have the guys who are doing hardware. Those guys are actually going out and doing lens stuff. These are good old-fashioned optics guys and electrical engineers who are building hardware. And then we'll run tests, et cetera. Then you've got the kind of software layer guys who are writing middleware to that. Who are kind of looking at what we're getting out of the hardware, what are we capable of reliably getting out of the hardware, what are we not getting reliably out of the hardware, what can we handle, what can we clean up with software. What can software do to improve what we're getting from the hardware? And then setting up that framework that the developer will get access to. What I like to call developer experience. We talk about user experience a lot, but developer experience is really important. And then developers taking that and applying it and doing things that we would have never imagined doing. Like the Jedi machines, for example. Who would have thought of that? But if I saw that, I walked. You stick those in a train station in Japan. I love vending machines. There's kind of that space of development, and then that kind of goes all the way down into the UX side, where we get stuff that falls into the lab, like where literally they'll drop in a piece of hardware and just say, "What would you do with this?" I don't know. So you have to start thinking about other technologies that pre-exist. What environments? So that becomes the framing becomes part of the problem. You start thinking, well, who would be who might be the person using this, and trying to imagine that person, like kind of modeling them out. That's always what I do. So I think of who's this going to be? Who is it that's going to touch this? How are they going to move? What are the spaces they're going to be in? What are the constraints of those spaces? How do we design to that? And so we start designing out, and then I'm constantly getting feedback from some of the more technical guys on our team who'll be like, we don't want to go down that road. That's like, we're not yet ready, and they'll start, well, don't go that road if we do something else. And an example of that, actually, that I want to mention how what this leads to in terms of a work environment that's kind of odd is I was told that our technology was incapable of doing something with reconstruction, basically. Like, incapable of reconstructing a face. Not reconstructing the face itself, it could do that, but do it in a way where I could just do this, and it would scan it. We have the way our technology works, the way it does registration, if you move your head and your chest doesn't move, it loses registration. Right? So if I do this, now the nose is in a different place in relation to the chest, and so now my mesh starts getting really muddy and ugly, and I don't really know what to do with it, right? Because it doesn't know this thing I segmented off and started to model is not the same thing, it's changing shape. So I had an idea that, well, we already have face recognition, and we have landmark detection. So why don't I just isolate the face and only scan it? And I don't know if that would work, and I got a lot of pushback from that. And I spent way too much time tinkering with it. But about 3 weeks ago, I have it working. And basically what I did was I realized, well, we already have the scanning. We're creating a bounding box for the object we're scanning. So if I scan the face, and the first stage was, scan the face. I isolate this little box. And now I only do the registration for the points inside of that box. The problem was I was getting this crazy blowback that, because I could not seeing the back of the head, right? If I was walking around you, then I could get you in 3D. But if I'm just looking at you from the front, I don't know what the back of the head looks like, so it blows off. But all I wanted was the face mask. So it's like, well, what I'll do is I'll get that, and then I'll just do do a planar cut, and kind of slice that off. I start trying to parse that. Man, this is a lot of vertices. Every time I move a vertex, I have to reconfigure all of my UVs, I have to reconfigure the vertex order, all the indices change. It's really ugly and complex. And it was taking up a lot of processing power. I was looking at it one day, and I realized, what if I just set the bounding box to be exactly where I wanted it to be shallow-wise? Then I don't have to render this stuff in the back in the first place, and I don't have to do the cut. So it's like two pieces that I'm trying to solve that don't even need to be solved. But I didn't know how to do that. The way we came up with was, we have landmark detection, right? So I can detect your eyes. So I just detect the edges of your eyes, I detect the edges of your mouth. I go to the depth buffer, which was a little tricky, and I find out what the Z dimensions of those points are, like how far in millimeters it is away from the camera. I create basically an average plane, or I create a plane that's based on that, and then did some calculations. By the way, if you guys didn't, you're doing calculations for the head, it seems as if the average head is approximately 7/16 as deep as it is tall. This is 7/8 is deep, but because I only want half of it. So what we did was we basically created a calculation off of that, find the face mask, push back a little bit, and it worked. So we just set a bounding box. So now what happens is I only scan the face. So you can just look at it and do this, and it just kicks out this flat-backed object that you can just connect directly to a character, for instance. So, but that was a problem that wasn't really a technical solution. Like, it implemented it as a technical solution, but all of the technical stuff already existed. We just weren't using it together. And that's the kinds of things that we're starting to see emerge now, is that there's technology that's been developed in all these different spaces. And putting them together has started to become creating some of the more interesting problems. Like you have to solve the initial problem of, okay, we really need to get better data, and that's still a problem. I think everybody here who works with this kind of stuff will say, we need better, cleaner data. And we all know that. The next thing is we need more usable software, which would be nice, like software that's actually reliable and clean and easy to use and kind of has some sense of understanding that somebody's going to use this in the real world. Because a lot of times that's when you're building SDKs. Developers often aren't thinking about developers when they build. They're thinking about themselves. Like, I need to get this done. I have a sprint. My sprint says, get this done by this time. They're not thinking, get this done by this time so that these guys have a great experience. This is my sprint says, get this done. And so that's kind of the reality of software development. But it's over time, those things kind of clean themselves up because you have to. So that's what we're starting to see there. And then there's also, as that's all happening, the complexity of the space starting to reveal itself. And so the same technologies can be applied in many different ways. So that scavenger bot, you can see that could be a game, right? I can have two people with tablets and they're playing games in the real space on this table, for instance, right? We can mess with each other, we can slide objects, and your guy has to run around, and we're playing like this way, right? On each end of the table, we're using physical objects. Or, in the first video I showed you, there's that architect who's looking around the space, and you see it's kind of like dropping lines on the window, because he's actually going to go model that space and go alter it, right? If I'm going to come into this room and look at it and say, okay, I'm gonna do some significant changes to this building. Then I'm gonna scan the whole building, instead of rooms, and then I'm just gonna go into a 3D software, like a CAD program, and start knocking walls out, and adding things in. But I'm working with the physical space that's there. That's another set of constraints. If you're trying to fly a real-world, multi-million-dollar device that, if it crashes, costs a lot of money, it's a different set of constraints. A lot of applications for that. Or even in cars. So what we're seeing right now is the auto industry is crazy about this stuff. They're crazy about it. They want it now. Which means for the auto industry, like 10 years from now. Because if the auto industry gets it today, it's going to take them 10 years to actually get it into a car and get it approved and get all safety checks in and all that. So, but they're already looking at things like, for instance, lane detection. So I'm sure several of you guys are all students, so I'm sure you've been sleep deprived at some point. And you know what that feels like to drive when you start, the eyes start to get a little blurry on the edges, and you don't realize you're tired until you're already starting to drift, right? You don't realize your eyes are about to close until you're already drifting. And so they're talking about designing cars now with that detection built in. I detect the lights go on, you basically vibrating steering wheel, like things that can kind of correct, bring the car back into the lane, and alert the driver. So those are just built in. So a lot of stuff going on with that now. Detecting state of the driver, context. So we're not only just getting that, but we're getting context. So already your phones are doing this, right? So any of you guys who have an Android device will probably use Google Now. If you don't use Google Now, I recommend tinkering, like just kind of keeping an eye on it to see what it knows about you. Interesting. I had it, for instance, give me directions last week to a place that I've never searched for. So a business that I've gone to numerous times, and just showed up on my phone and says, do you want business, not to the location, but to the name of the business. And it was a place I looked down, I've never searched for that. How did it? And I realized, because I go there almost every week. I go eat there on the same day. And it was that day, and it had those GPS coordinates, and they did their GPS coordinate check, compared it to their business, their information from Google Maps. Gate got the name of the business, and they said, "Hey, do you want directions to this place?" So all I do is say, "Yeah." And then what it does is say, "Okay, well, we'll route you around, the bad traffic that's on this route, because there's an accident with this other thing, right?" So I didn't have to type anything, I just pushed the button because it knew my behavior. So as that stuff is starting to be combined with these sensing technologies, we can sense things about the world, use that to build context, but then we can combine it with context we have from other sources in order to be able to adapt what we're sensing in the local space, right? So we can sense what you're doing in a local space, but we know what your history and your behavior has been over a larger space, and now we can craft very, very specialized behaviors for the system. And that's kind of where we're going. That's the hot stuff we talk about in the lab right now. It's like the thing we're really excited by is when we start to think that we always talk about the speech engine from Google. We've got a speech engine that's pretty good. It's a local speech engine. And it's pretty good. Google has a lot of data. And everybody who puts in a voice adds to their data. And then they crunch it, and it's just better, it's just better, it's just better. It's like, sometimes I'm amazed. It gives you an idea of, when I talk about the kind of weird, obsessive, not safe, I'll mumble at my phone purposefully to see how much it can understand. Like purposely kind of try to mumble, talk with my mouth full. I try all kinds of things just to see what it will understand and what it won't. And it's getting really scary good. But that kind of context of seeing, so right now that's speech recognition, in the sense of speech recognition. We can also, we're getting better at doing voice recognition. So, and it's not just about a voice said this, it's your voice said this. And that's a big difference. Because if I know it's your voice that said this, I can have specific behaviors for you that are different from you, and different from me. Right? And that's kind of where we're getting, or face recognition. We often hear people say face recognition when they mean face detection. Face recognition is I know the difference, I know who you are, right?
Yeah, Vegas does that.
Face detection says I know there's a face. Facebook, did you see? I don't know if you guys saw that article about Facebook's face recognition algorithm. Its recent score. I really want to see that test, because apparently it scored 97% accurate on identifying faces, which
Yeah.
is basically a half a point below a human. That's creepy. Like, I mean, creepy good, which means it's going to be better than humans overall. That's pretty good. And that's kind of where we're getting. And the thing is, like, right now, these pieces are kind of disparate, and there are people doing research and work in each of those areas. But I'm sure you'll see, for instance, in Malcolm's Personal Hills lab, I've seen those guys like working on things that seem really far apart, right? You walk in, you're like, this project and this project seem like they're miles apart. But the thinking that goes behind, like, understanding how to approach those problems is really similar. And that's the thing that hasn't really developed yet. We really don't have a solved engineering space yet. You know, where I get a set of problems come in and I look at the constraints and say, okay, well, I know bridge building is a great example of that, right? Like, I know how wide the span is. I know what kind of surface is on either side. I know what bridge I'm building. Like, it's no question. Like, that's the bridge I'm building. It's pretty much straightforward. Now, how I make it look and things like that, that's all. But for the most part, it's pretty much a solved problem in that regard. We've been building bridges for a long time. We know what works. We know what doesn't. And we play it safe with bridges, which is probably safe. Oh, good decision. But for this space, we have none of that. So the design thinking, the problem-making thinking, the understanding, the starting to develop the field. And the only way to develop the field, like we see this in the lab all the time, we'll have companies, because we've moved into a product cycle, you'll have a company who's never touched this kind of technology before, but is a very good developer, think that they can just push this right in. And everything that worked in the other, you know, in a 2D way of interacting with a keyboard and a mouse is going to work. Like, oh yeah, you'll just do this. Like, as soon as I hear the word just, all my alarms go off. Like, how about you just give me an 8-foot vertical jump? Like, it's like, just happen. I mean, I know you know what you need to do in order to make it happen. There's a big difference between that being realized. And so that's kind of where we are. And it's kind of give you an idea that the space right now is really open. The best way to explore it is to actually make stuff, to tinker with it constantly, to make things, physical things, virtual things, combine them, play with sensors. I don't know if you guys know about SparkFun. If you don't, go check out their website. SparkFun is you can order them Adafruit. You can order parts for anything, sonars. You know, sonar's awesome. That's actually one of my favorite, most recent tinker tools. Very reliable crickets. But you can get these pieces and start to kind of build your imagination. Also, don't throw away your old phones, right? Like, you get a new phone. We have fast recycle rates on our phones, right? We get a new phone, and the old phone is pretty smart already. We just kind of get rid of it. You don't even think about what you do with it most of the time, right? What you have in there is a machine loaded with sensors and a great processor. Okay? Think about what you deal with what you do with those of you who deal with Arduinos. You're talking about what, 20 megahertz of processing power? Maybe, right? This guy's got 4 cores, 1.7 gigahertz, you know, lots of RAM, gyro, accelerometer, GPS, camera on both sides, microphone, and already a software development system for it. Like, not a bad thing to start with if you want to hack at stuff. So, and I think that those are things to start thinking about. So what do you have? And play with it. Because that's kind of what gets. We often, when we want to bring people in the lab, that's what we want to see. What have you? Depending on your role, right? If you're a researcher, we want to see how you approach your research. It's not even what the research is nearly as much as how you approach it. Like, well, how do you approach your problems? What do you do when you run into problems? Because you're going to. Right? We're talking about, we all want to find these golden gems, right? These gems of like, oh my God, we found a way of getting people to use this thing. And it feels right, and it's tight, and all the behavior is just sweet, and like this interaction is spot on. But you go through a lot of stuff that isn't that before you find one of them, right? And you know, we were really excited. These guys had a paper for Kai that I was really excited about because it was a step. It was like a step where I'm like, that interaction works. that works. That's a solid interaction that you can build on. And those kinds of things are kind of how this works. Kind of, in the end, what will happen is 20 years from now, somebody will look back and they'll have this like, oh, it was this great time, everything was just cool, and instead of making of, and they'll make something like, it'll be romantic. But if you were at Xerox Park in the 70s, I guarantee you were frustrated. So I wanted to answer questions for you, Jess, too, mostly. So I'm kind of like what your interests are specifically, and kind of like coming at that, and how it can kind of help you guys get a feel for where you are and where you might want to be, and that sort of thing.
I have a question, although it's not related to that. It's more philosophical. Because I know right now you're obviously in this development cycle, so all the philosophy and the beer talk is, in some respects, gone. You're busy academic project. But I was wondering if when you guys get together and you talk in the long term, I mean, what you're essentially describing is when you're talking about sensation or perception, you're not, I mean, right now you're talking mainly about vision and some other things, but there's lots of other perceptual modes. You mentioned, for example, sonar, but I'm thinking of other biomimetic things, things like the lateral line of fit. I mean, there's all kinds of ways. I mean, essentially, what you're talking about in the long run is essentially describing designing your own sort of central nervous system for these machines. So I'm wondering if, you're not going to bring it to your bosses at Intel and say, oh, we're thinking about fish. But privately, do you think about these other, although I know, before you answer it, I know one of the problems is like sonar, most of these things like the lateral line involve other kinds of, they have to put something out. They're not, the great thing about vision is it's all coming in. Sonar, lateral line is electromagnetic fields. You have to actually interact with the environment, but that's not beyond the realm of the doable. So anyway, that's my general
That's
question.
actually it's a good question. Are you guys familiar with what's been going on at the University of Washington with using radio waves for gesture?
Yes.
You know that?
Yes.
So they've been pushing it too. Like they go a little further and a little further. And like when I saw the first work a while back, one of the girls in our lab worked with, was at that lab at Washington, worked with some of those guys. And her take was, it doesn't look like it's going to happen. And then when she saw the first paper that came out where they had used Wi-Fi to detect gesture, we're like, well, it's like it's something. It's like there's something. I don't know how reliable, how specific, but they're basically using, and then they kind of stepped up to general radio waves. And they're starting to get more specific. But the thing is, like, even if you can't detect specific gesture reliably, which they seem to be moving toward, that's the goal, you are detecting a moving presence of a human in a space. And that's something significant in and of itself.
Well, that's what sharks do.
Yes.
I don't think they know what it is. They just bite anything moving, but they definitely detect it.
Yeah, it's there. There's something there and it's moving,
Right.
and I might taste it.
Right. If I don't like it, I'll spit it out, but otherwise
So that's something that's really good to be trouble with. That thinking about the sending out, is that we're really bombarded with there's constantly fields around us. And if we can tap into the fields that are already there, we actually have a lower power solution that's hijacking what's already there. So some of this is there, and we are talking about that. And some of the others is things like, so our team, in particular in our lab, we're all somewhat serial hobbyists. So I competitively fight, I climb, run, etc. One of the guys we train with is training for, he's an alpine climber. He climbs Mount Kinley, he climbs in the Alps and the Himalayas, and ice climbing and that sort of thing. And he's now training for a half marathon. Lots of physical people who are doing things. One of the guys is an autocross racer. And we all are always thinking about this technology in terms of what we do. For me, proprioception is really interesting. Right? Like that when I'm training someone, for instance, one of the things I'm always thinking about is the proprioceptive awareness of a body. And it's one of the hardest things to develop. For knowing when somebody's left hand is a little too low. I mean, the difference between where it should be and where it is not good is almost indetectable to you until you develop that feel. It takes a long time to develop it. But we could actually we could use technologies to kind of, if it was, they knew of their awareness and proximity to themselves, the technology could actually help with that. We've also talked about it actually for rehab a lot. And prehab. That's one of the things we talk about, like, actually is a big interest, right, for some of the guys in the lab is prehab. Is the idea that you help people move well so they don't need rehab later. Because that's a big problem. Like you'll be moving in a way that you don't realize is causing significant damage to your body over time. And being able to detect and correct that by giving feedback. So yeah, we're very interested in a lot of those kinds of sensing technologies. Right now, the effort, like you say, is it's going to go to where it is. Yeah. But we've got some simultaneous efforts going on that are looking at things like electrical signals in the body, heart rate, things like that. You guys saw that, that work that MIT did with the heart rate with using a webcam. And it's really nice stuff. And experimented with some of that. EKG reading, that sort of thing. So, I don't know if you guys saw I tell Bob Basis. So Basis is a watch that has all kinds of sensors loaded in it, and Intel just bought them, which I guess means we are going to do the wearable thing. So it's been.
I was going to ask on the sense of preceding, and you were talking about gestures. Were you talking about gestures just of like the arms moving up, or just like facial recognition and actually that?
All of those.
So last semester, or actually last year in January, is when I learned to play poker. A roommate taught me to play poker for the first time, and I went in there, thinking a little bit like an engineer, and I started taking everyone on the table and creating a little profile for them. I'm like, this person does this during that, and et cetera, and also taking those of facial recognition, just taking in all that data, and actually won this past year I've won $1,500 just playing poker. Just keeping to the sets of standards that I wrote down from day one. Yeah, I don't know. I really find a lot of interest in being able to take in that data and then using it in a meaningful way.
Have you guys seen Elvis? Like I think that what you're describing, there's a program from it's a robot. Oh, not a robot. So Elvis, I tried. Add border to it. It's basically doing that. And the idea is that humans have there we go. So what you got is this machine that people walk up to. It's like a pre-screen. And the idea is that humans are pretty good at reading information. We're good at thin slicing, but often we have a hard time making sense of the data we're getting. But we're also really biased. And understanding that we are really biased is the first step of getting to a better solution, right? So like even when we don't want to be, like some of our biases are actually good for us, so we don't want to get rid of them. They help us, right? Like detecting danger, risk, physical attraction to another human being, things like that. Those are all biases. And so if I'm a customs agent and I'm attracted to the person standing in front of me, it's going to alter all of the information that comes into my senses. I'm just going to receive it differently, and I can't stop that. Like I can mitigate it, but there are going to be changes. There was a great study done on that. We had a female graduate student go out to a large, like a state park, and people were hiking, and she would just ask them a series of questions about the park. And at the end, she would say, if you have any questions, give me a call. This is my number. She's like, "Hey, Mom." And what's interesting is she took them out. She did it at numerous locations around the place. And then there was a swinging bridge as part of the park. And on the swinging bridge, the people who she asked the questions on the swinging bridge and then gave her phone number called at a 60% greater rate than anyone anywhere else in the park. The reason is because and what's funny is people go, oh, it's surprising. Researchers are all surprising. We knew that was going to happen. It's because physiologically their heart rates their heart rate increased. They shorter breathing. They were excited. They felt anxiety. But that's exactly what you feel when you get that flutter or maybe an attraction to someone. So what happened is they would get the flutter, and then you put this face in front of you, and you map the physical sensation to the body in front of you associated with that rather than the fear, and now you think you're attracted to this woman. So, guys have been doing this in horror movies for years, right? It's basically brain hacking, right? So what this does, the idea behind it is that we can try to eliminate some of those biases or reduce those biases. And systematize those biases and detect. So basically, it's looking at eyes, it's looking at pupil dilation, heart rate, breathing pattern, eye scan pattern, all kinds of things. So it asks a series of questions, and it tracks all of this biometric data about the way a person is behaving, moving, etc. And then from those series of questions and the data, it flags them whether they're okay to go or whether they need a human. And then the human will come and give them a deeper investigation. So, like what you're doing in poker, basically customs build something that does that for border control.
Nice.
So this is, that stuff's coming. It's kind of detecting all of that. The heart, the kind of the galvanic skin response. Like I would love to have that for people sitting across the table with me.
Yeah.
With insight switch, kind of understand what's going on. Yeah, that's a huge deal. We've been wanting that in games forever, like to know, because that galvanic skin response is magic. It's like just a little burst, and there's the excitement spike. Got it. And now can take it and leverage it.
Just a general question. I thought I'd read something about this once upon a time, but then I heard nothing else about it, so maybe it's not the case. But did Intel somehow pair with I think it's a Belgium company, Soft Kinetic, to do some of their stuff for the depth camera and the laptops and stuff? Or
for RealSense, for the first generation, right? So for the first camera that came out, that was the developer model that's been out for a while. That one, the creative, based brand new creative camera. That one we worked with Soft Kinetic on in the original on that model.
Okay.
It was kind of like first gen hardware to get stuff out, and they basically, I think the way I wasn't there when they originally licensed it, but it seemed like they got a portion of their core code and hardware, but not everything that Soft Kinetic did, and then built that with it. So it's like take this piece and then build it out.
Okay, so then whatever's going to be attached to the laptops coming in the future, it'll just be proprietary for Intel, whatever. Okay, cool.
Yeah. So
does Intel do any sort of research or development with music and integration with music and technology? Maybe using a Fourier transform, or I don't know if you guys have something better.
That's a good question. I know of nothing that's a formal project. That being said, I just lost a pitch for I.O. I don't know if you guys know about I.O. Festival in Minneapolis, but big creative coding festival. A group of us just made a big pitch for I.O. for this place. It's basically a festival that runs overnight. The last night of I.O. called Northern Lights. It's an all-night art show. So there are all these installation projects that go in. And a big group of us from my team just made a big pitch for it. We found the most problematic space we could find and then pitched for that. And we just found out we didn't get the space. Kind of frustrated, a little bit flabbergasted. We couldn't believe we didn't get it. And then when we found out who beat us, it wound up being somebody else on our team. And we didn't even know they were pitching. And they pitched for the exact same space. Like, why would you pitch that space? It's terrible. He was like, that's why we chose it. That's like, the guy who pitched it is a musician, actually. And while I was here, he's actually been watching post pictures. He did a whole project, an installation piece with an adaptive piano, which basically plays based upon the movement around it, and worked with a composer who built the physical piano and crafted the music for it, and then he worked on the interaction.
Did they put that in a mall and like video record people? I think I saw some.
Yeah, it was in the mall,
Yeah.
and now it's in the Tech Museum.
Yeah. And it reacted depending on how.
Yep. That was another thing. So we don't have. So people on our team have backgrounds like that. The people around Intel have backgrounds, and then there's the Creators Project, which basically is Intel funds artists and people doing really, really cool stuff. And basically just throws money at them and says, "Keep doing what you're doing. Please make beautiful, cool stuff." I want to find out how they do that. That's my escape route.
Other questions?
I have questions for some of you guys. What do people study here?
Electrical engineering.
You were trying to see
Several.
So,
I got a question. So I'm actually not an engineer. I'm actually from psychology.
okay.
I'm a psychologist. So, I want to ask if what's Intel doing, or are there any projects related to like physiological stuff? You know, like looking at brain waves, looking at blood velocity, oxygen levels, stuff like that.
There's a lot of work going on in that space. We right now aren't in the space. We're doing some, I've seen some investigations into more, EMG, EKG,
Right.
That kind of stuff. But haven't really started getting into the neural stuff that I've seen. Now that being said, to explain something about Intel culture, it's not every Silicon Valley culture, has its own culture. They're all kind of weird. Intel's no longer a big company. It's now a small city. Over 100,000 employees around the world. We have our own internal website that isn't just a website, but basically it's like a whole internal set of information where I have just an internal research site where it's just research that people from Intel have gathered, done, found, located, and put together and then organized by topics that's just available. So that's the first place I go with all information. It's huge, which I didn't know existed until a marketing guy told me. And then, so we've got kind of these divisions, but because of that, what ends up happening is you end up with these small divisions, and people protect early, right? Because we call it premature collaboration. Right? You don't want premature collaboration because what ends up happening is you have too many managers touching the same project, and then everybody has an interest, and everybody has their own, we call ARs, their own actions that they have to take, and so their AR interferes with your process. So you just try to get something to a point where it's already got wheels, it's already got an identity of itself, and it's ready to move, and then you can start mixing. So with wearables specifically is a good example of kind of we had a possible internal conference come up about wearables, and it became so huge of all these people who were interested in or working on wearables throughout the company, and nobody knew. Nobody knew. We had a wearables group, but they were just one of the groups, and it was the smallest piece. Actually, there were people all over the company doing these wearables. Nobody had any idea because nobody was communicating. Because they're all in different places, they're in different physical locations, different wings. So if there's something going on, I probably wouldn't see it until it came out of the room, or until I bumped into somebody who needed something I had. That's usually how it works. Like somebody said, it's like, hey, so I saw this. Would you be willing to come in and help out? Let's go have lunch, or you go for a walk, and they let you in. Come poke around our lab. All of our labs are scanned, so you have the big buildings that you walk around, but when you get to like our lab, you still have to, if you don't have a badge to get in, you just don't get in. So always people just kind of, we talk about, someone asked me, you're in that room where they do the sex. That's what I hear from them, because it's all the marketing folks around us. All they see is the doors, and they see us come in and go out, but I never really thought about it because I'm just always going in and out of the lab. I never thought about what it looks like to people who don't know what goes on inside that room now. It's just like you see people come in and out. And sometimes the door will open and there'll just be, like a chopper, like a quadcopter just flying. Like somebody wearing an Oculus Rift and walking around with a helicopter. What's going on in there? So, that's the kind of space. So if that's happening, it's probably happening in a very specific place where people are trying to nail down the space. There also might be some research stuff happening. And that's the other thing. So where you'll build a relationship with somebody who's doing research and is trying to provide technology and assistance in that regard. So I don't know. They did send me to the Euro Gaming Conference last year. And I don't know if you guys have seen that, but
I haven't. Was it good? I want you to go to that. I wasn't able to go.
It's really small.
I'm going to go to this one. It was small?
It's really small.
I'm hoping to go this June.
It's super small. Like it's everybody. You'll get to know everybody there. It's
Right.
so
That's why I want to go.
And it's right now we're seeing pretty good. I saw one gelless Euro controller, which was nice because most of them you put in a gel, kind of.
That's what I'm doing is going computer interface.
Yeah, so
We're
that's
developing that actually here. We're trying to build a lab to do brain computer interfacing.
that'd be great.
Yeah.
There's I don't know if you guys have seen Tactical Haptics, but it's a really cool company that just started in terms of feedback for these sorts of things, because a lot of times what we're working with is we're working with one side of detecting, but there's also the feedback side, feeding back to the human, right? And a lot of times we just give straight visuals, and on screen, you know, or I just made a pitch that I think the audio is what did it. Like I just basically tried to, like, I couldn't get the visuals done in time, so what I did was I just tried to make the sounds sell every interaction. So so you'd see things that weren't really there. We trust our ears. So, but this guy, what he did with tactical haptics is he was a professor in Salt Lake, and when he realized this, we were talking about earlier about this with skin, is that most of what you get from when you pick something up, the feedback that allows you to adjust and be facile with it, actually comes from surface tension on the skin, not from the weight itself, because your muscles are really not that good at that. They're really not good at sensing things like that. And so what he did was he made a controller, and all he did is, I don't know if you know, these 6-sense controllers. So, another's really cool. He took a 6-sense controller, and he wrapped it, he made the 3D printed this kind of wrapper for it, and he put 4 little plastic pieces in it with linear actuators on them. So you just move up and down.
I've used this.
Have you used that one? It's weird, right?
It gives you this, does give you feedback. It's just a little bit not what you expect.
It's a little weird. You have a pistol, like he has one pistol deal with Unity, and it kind of jumps. It's pretty good. The one that really messed up was troubling me was the sword.
Yeah.
It's strange. Because you feel the impulse to stop, and it's moving. It's weird. It's like it tells you that you bumped into something. You kind of stop, but there's no. It's really strange. You start to realize that when you're feeling one piece of something and then missing other pieces, it's really strange. So you react to it, but your body is definitely in a state of kind of wondering what's going on. So it's very strange to be able to feel, because I would stop, and I'm like, well, that's interesting. I physically stop when I come into contact, but something is odd. It's very strange.
What was the name of that again?
Tactical haptics. So there's a lot of that kind of stuff starting to emerge where we're getting pieces of it, right? And kind of putting together. I like to play a lot with behavioral stuff, with adjustments, stuff we use in film and games all the time, to feel comfortable to people. But feedback is a big problem. It's a big problem with some. And that's where I think a lot of actually folks from outside of computer science would be really helpful. You need computer scientists to build and understand, and engineers, and that kind of thing. But it's parts of it. But we need folks who understand human systems very well in order to contribute. So.
Okay, well, I think we have to stop.
Cool.
Let's